a privacy-preserving, context-aware insider threat prediction and prevention model predicated on the components of the fraud diamond by Solomon Makonnen. The problem: insider threat can seriously affect the organization, resulting in financial loss and a loss of reputation. Insider threats are difficult to address because insiders are authorized to access the system. The insider threat problem requires a wide range of solutions combining the technical, social, and organizational dimensions because human element is involved. The question is, how can we predict insiders and prevent their attack using approaches from psychology, criminology, and computer science? Theoretical framework of the model: fraud diamond. Crissey in 1953 proposed the fraud triangle, which argued that three conditions need to be present for fraud to occur: pressure, opportunity, and rationalization. Opportunities are environments that are conducive to fraud. Pressure refers to the factors that motivate employees to commit a crime. In addition to pressure and perceived opportunity, fraudsters need to justify the crime to avoid guilt and shame, which is rationalization. Wolf and Hermansen in 2004 upgraded the fraud triangle to fraud diamond by including the fourth element: capability. Capability is essential for insiders because they also need to have the skill to commit a crime. In this paper, a model based on these four components is presented in order to mitigate the insider threat. Here is a proposed model. We present a novel interdisciplinary insider threat prediction and prevention model which combines several approaches, techniques, and tools from computer science, criminology, and psychology. It is based on the fraud diamond, which comprises four components: pressure, that's motive; opportunity; capability; and rationalization. The model presented here involves three major components: context awareness, opportunity facilitation, and neutralization mitigation. The deployment of a context-aware interface involves gathering information about the insider's possible intent and the ability of the insider. This will help to identify high-risk insider threats. The model will grant an opportunity to high-risk insiders only to commit a crime using honeypots. Based on the insider reaction to the honeypot, the model will deploy an implementation strategy based on neutralization mitigation. Neutralization mitigation is a process of removing the rationalization that the insider may have had for committing the crime. The model preserves the privacy of insiders using only metadata, excluding content, and anonymizer, which removes identifiers. Components of the model: there are 7 components. The first component is user taxonomy. This component categorizes user into 2 dimensions: system role and sophistication. System role includes novice, advanced, and administrator. Sophistication includes low, medium, and high. The second component is user profiling. The user profiling component will be used to assess the user sophistication level. This profiling component will use metadata such as the number of errors and warning message generated by the user to assess the sophistication level of the insiders. The third component is context analyzer. We propose the use of analyzer to predict a high-risk insiders based on metadata such as search behavior, file access, logging, using keystrokes and linguistic features without collecting the content to balance privacy issues. And the fourth component is honey token. The model facilitates an opportunity using honey token, which is a deception trap, to determine if the insider will be lured into crime. And the fifth component is decision manager. The decision manager will use all the information in the previous components together with the user taxonomy to predict insider behavior. Factor motive. The motive of a user is assessed using its current stress and usage behavior level, which will be determined by the metadata analyzer. The stress level includes 3 results: low, medium, and high. The second factor is opportunity. According to the fraud diamond, a malicious user requires an opportunity to commit a crime. An opportunity is measured by 2 parameters, namely system role and honey token. The third factor is capability. The skill of the user is determined by the user sophistication, and it can be low, medium, high or very high based on the type of application they use and the level of computational resource usage. Decision algorithm. The decision manager component of the model will decide which employees are likely to be malicious based on the assessment of the above factors. Users will then be classified into 3 categories: low, medium, high. Hence, if a user is assessed as a user with a high motivation, medium opportunity and high capability, then his threat score equals 8 points, which makes the person is a threat. The sixth component is neutralization mitigation. Rationalization occurs when an employee justifies the reason for committing a crime. For instance, an employee who violates the high security policy of an organization might say that his or her act is not forbidden. This paper adopts the 6 techniques that have been proposed by Sifnan and Vance, which include denial of responsibility, denial of inquiry, defense of necessity, condemnation of the condemners, appeal to higher authorities, the metaphor of the ledger. This component will alert the at-risk insiders about the information security policy based on the neutralization technique that are discussed above. It also gives the management team input to help them reset rules based on the neutralization technique that might be used to remove an excuse for committing a crime. And the seventh component is privacy-preserving filter. As privacy-preserving mechanisms, the model uses only metadata, excluding content, and we will also implement anonymization, that's removing identifiers, technique to protect individuals' identity when releasing sensitive information about the potential insider threat. This information is fed back into the management team in order to develop strategies to prevent future attacks. Proof of concept. The proof of concept is a simple interpretation of the model. The model uses an asset management system as a case study. The system will produce an anonymized report of suspected insiders based on their motive and their capability. For the suspected insiders, honey token will be provided as an opportunity to commit a crime and will deploy an implementation strategy based on neutralization mitigation and based on their reaction with honey token. Finally, the system will produce anonymized reports based on behavior of insiders. A demonstration of the proof of concept is contained in the subsequent video. Conclusion: this paper proposed a novel, privacy-preserving insider threat prediction and prevention model which can be used in real time, combining approach from computer science, psychology, and criminology. The model uses context-aware metadata analyzer and user profiling to assess the current situation of insiders in order to determine the risk level of users for committing malicious acts. Thereafter, at-risk insiders are mitigated through a process called neutralization mitigation. The result will be used to advise and warn those users who are at risk of insider threats. That will remove excuse and alert the insider. Thank you for your participation.